the well-grounded newbie, advice for Ruby newcomers and their mentors. I know that not all of you are Ruby newcomers. In fact, I see some reasonably seasoned Ruby programmers in the room. But as you'll see, this is advice partly for newbies and partly for people who might have occasion in turn to advise or mentor newcomers to Ruby. Just a couple of words about me. I started using Ruby in 2000, which was when the Pickaxe book came out, the book Programming Ruby by Dave Thomas and Andy Hunt. I sort of stumbled on the book literally, well, manually anyway, at a bookstore right after it came out, and I've been hooked on Ruby ever since. I'm one of the directors and founders of Ruby Central, and we're the parent organization of this event as well as Rails Conf and other projects. What are we going to do today? Well, we're going to learn some what I consider major common points of confusion. Essentially, what I've done here is to choose, and this is a purely subjective choice, but I have chosen points that I think, because I've seen it happen over and over again, I think are particularly either difficult or tricky or in some way kind of hard to grasp, particularly for newcomers. So we're going to look at some of these points, and hopefully this will improve both your ability to understand code and to write code, because you'll see exactly what's going on in some of these cases. We're going to look at 7 points. Again, this is purely subjective choice. 7 points that I think are common stumbling blocks. And I should add, it's not just for absolute newcomers to Ruby. This is my choice of the 7 points is based on years of training Rubyists, including people who are not necessarily complete beginners, but these are things that I've seen people kind of have trouble with again and again. And we'll look at how these particular 7 points can help you understand Ruby. Questions throughout. If you have questions, just go ahead and raise your hand, and we may have some time at the end too, but if as we go along, if you have questions, that's fine. I'll try to accommodate them. All right, so we're going on this little trek through 7 points, custom chosen by me to help you get a handle on some of the tricky things in Ruby. Okay, every expression evaluates to an object. You will sometimes hear people say of Ruby, everything is an object. Everything is not an object. For example, an if statement is not an object. An argument list is not itself an object. It's a syntactic construct. Keywords are not objects. So there are things in Ruby sort of peppered throughout the code that are not themselves objects. You can point to something and say, that isn't an object, it's a keyword, or whatever. But everything does evaluate to an object, including things like if statements, method definitions, class definitions. So everything evaluates or reduces to an object. And we're pretty used to this with if you just type in like the number 10, it evaluates to the number 10. But here's a couple of ones that you might come across and not know exactly what to expect. For example, a failed if statement always returns nil. So if you say if something and it's not true, and there's no branch of the if that returns true or that evaluates to true, the entire if statement, those 3 lines, evaluate to nil. So everything reduces to an object. An if statement reduces to an object. In this case, it reduces to the object nil. And it never reaches that middle line, that string not reached. So this is a failed if statement. The puts or puts method also evaluates to nil, and sometimes, again, especially if you're not used to IRB, which has this read, eval, print loop going, IRB is very literal. If I say puts hello, it will obediently print the word hello, but the entire operation, the actual call to the method puts, returns nil, and puts always returns nil. It does not return the string that it prints. It prints the string as a kind of side effect, and it returns nil. That's why you get in IRB, you get the string printed out, but then you get nil as the return value, the evaluation of the entire statement. Empty class definitions. Now, this is a little bit arcane. There's not too many use cases where you care what a class definition evaluates to. You care about defining a class. You don't necessarily care what the class definition ends up reducing to. But there are a couple of use cases, and it's, I think, just instructive to know that a class definition does have a value. An empty class definition evaluates to nil. So if I say class C and, that's an empty class definition, it's nil. If you happen to have an object other than nil as the last value in your class definition, the entire definition will evaluate to that object. So the value of those 3 lines at the bottom, class C, some value in a class definition end, the value of that statement is the string some value in a class definition. So again, everything reduces to an object. And when in doubt, if you're sort of wondering why something's nil or why something isn't nil for that matter, think about the literal kind of looking at what the statement or expression reduces to. All right, point number 2. It's all about sending messages to objects. This is not an obscure point. This is kind of the lifeblood of Ruby. But it's worth noting that, and I think this is one of the kind of really interesting and cool characteristics of Ruby, that it's all about sending messages to objects even when it doesn't look like it is. So, for example, you have messages that come after dots. Those are kind of the sort of bread and butter ABC dot upcase. That's sort of the most kind of canonical way to send a message to an object. You put a dot after it, and then you put a message. In this case, the message upcase. However, infix and unary operators are usually also sending messages. And I'll show some examples too. Square brackets are a message. Case statements also end up sending messages to objects. So let's look at a couple of these. For example, 3 plus 2 in Ruby, that infix plus sign is actually a method call. It's actually essentially it's 3 dot plus with the argument 2. So you're sending the message plus sign to the object 3 with the argument 2. Ruby very nicely allows you to write it as an infix operator, but you're literally calling a method whose name is plus sign. The same thing for most of the other arithmetic operators, including star and division and so forth. Square brackets are another one. If you look at A sub 2, I use the word sub for square brackets. I think that's very old school, I'm not sure. But what I mean by sub is A square brackets 2. The object A in this case has a method whose name is a pair of square brackets. And I'm calling that method with the argument 2. So again, I'm sending a message to an object, even though Ruby, because of it's what it allows by way of syntactic sugar, so to speak, Ruby has it looks like syntax, but it's actually calling a method, in this case, the square bracket method. Interestingly, even the unary plus, the plus sign in front of an object, can actually be defined through this method called plus @. Now, this is a kind of bogus example because you can't actually call it with a dot. So this is more just to give you kind of an x-ray of the fact that the behavior of an object in the face of a unary plus, a preceding plus sign, will actually be determined by that method. For example, let's see if, can we get, this is an IRB session in a slightly malformed terminal. Well, I think you'll be able to see this. If I say something like class person, why do I feel like the indentation is weird here? Let's try this again. Okay. Class person, attra reader name. This is just a very simple, we'll say initialize name equals name. And now I'm going to define plus at sign. And I'm just going to define it as name.upcase. And you'll see this just allows us to kind of follow the dye through the bloodstream, so to speak. So now I'm going to go David equals person.new. Hope is this going to run off the screen? It probably is. How clever of me. Just invented the mouse. Okay. David equals person.new. And will give me a name. Now, this is just sort of whimsical example, but if I now say plus David, I get my name in uppercase. Right? In other words, I have defined the logic for the unary plus sign, and it behind the scenes involves sending a message, calling a method, and coming up with the result of that. All right. So operators are mostly methods, and this is actually just an example of the regular plus sign. In this case, I hope it's not too small, but I mean you can sort of experiment with this too on your own. This is another person class. It has an inner class called couple. The idea here is that when you have a couple of people, which you achieve through a plus sign, you get, if you look at where it says def 2s, basically the string representation of a couple is the two names joined by the word and. So if I say John equals person new, Marcia equals person new, give them the appropriate names, then I say couple equals John plus Marcia. What happens is the plus method gets called and it returns a new couple. And then if I print the couple, it falls back on the 2s method for couples and it prints John and Marcia. So basically you can, again, this is sort of whimsical example as most of them are, as you'll see, but you can basically do what you want with the plus logic, but again, it's always calling a method, and by the same token, you can sort of hook into it by defining that method. Yes?
In the previous example, your def was the unary plus.
Right.
Plus at. What was that?
That's just the name of that's the name of the sort of the hook you have to define. So yeah, I mean, if you define just plus, then you get the infix operator syntax. If you define the plus at, it gives you the unary plus behavior. Okay, another, I think, really prime example of a case where Ruby looks like it isn't sending messages to objects, but it actually is the case statement. Now, if you look on the column on the left, and just ignore the rest for the moment, I have case some string, which is whatever, when ABC, which means if the string is the string ABC, do such and such, ... When regular expression DEF, if the string matches DEF, do something else, end. Case statements in Ruby are governed or engineered by this method whose name is 3 equal signs. Now, or the 3-qual operator, if you will. What actually happens under the hood when I say when ABC, I have a when clause, what's actually happening in terms of what Ruby's doing is it's saying if ABC 3 equal signs some string, right? If I say case some string when ABC, I'm really saying if ABC 3 equal some string. And that, in turn, is really just syntactic sugar for this. There is a method called 3 equal signs, and if, like the plus sign, if you use it as an infix operator, you're actually calling a method. Now, this middle one where I use it as an infix operator, that's sort of a, kind of hypothetical. You don't actually necessarily see that. I mean, when you do the case statement, this is all, wrapped in layers of syntactic sugar on top of sugar. But what's really going on is that I'm calling the 3-qual method, the 3 equal sign method, on the string ABC with the argument of my case expression, some string. Now, what this means again is that you can also roll your own. In other words, if you want to define your own case behavior, how are my objects going to fare in the face of a case statement? Well, here what I've done is, again, the good old class person. I've now got name and social security number, so SSN. And up there in red, I've defined my threequel method. And what it basically says is, the threequel method returns true if my social security number is the same as the social security number of the argument to the threequel method. So what happens then, I create David with a number, Joe with a number, and mystery person with, as it happens, David's number. So now we're going to see which person is the mystery person. Well, when Joe, put as it's Joe, when David, put as it's David. And again, this is based on Joe threequel mystery and David threequel mystery. And of course, it turns out to be David. So you can actually govern the behavior of your objects in case statements by hooking into this threequel method. You never actually, other than defining it, you never, for case statements at least, you never actually have to type it. It just happens automatically. But that's kind of the underpinning of the case behavior. All right, so we see messages are being sent to objects even where it doesn't necessarily look like they are, as in case statements and infix operators. It is also true, and this is our third point, that objects resolve messages into methods. Now, I am splitting hairs here. I am kind of putting in a wedge between the message and the method. In normal conversation, right, we send messages to objects, or we say, you know, I called the upcase method on this object, or I sent the message upcase to this object. You probably more often say I called the upcase method on this object. Method and message are, you know, there's a little bit of fluidity just in kind of how we use them most of the time. But I'm driving a wedge through them. I want to be clear about the difference between sending the message and calling the method. My take on this, and I've actually gotten in trouble on a mailing list for saying it this way, but I've thought about it and I've decided I'm sticking to it, that objects do not have methods. Now, it is sort of a half-truth. I mean, you can say, yes, a string has an upcase method. But what I mean by this, when I say objects do not have methods, what I mean is that the method itself does not live in the string object. The method itself, every method lives in a class or a module. There are no exceptions to that. Methods are defined in classes or modules. They're not defined, even a method that you define on an individual basis just for one object, that method, and you can do that in Ruby, defining singleton methods, that method still lives in a class. It lives in what we call the Singleton class of the object. So every method, even if it's just a method on one object, every method lives in a class or module. So that's what I mean when I say objects do not have methods. Objects have intelligence. You send a message to an object. The object has the intelligence to search through a predetermined path of classes and modules to find a method that corresponds to the message. So I send the message upcase to a string. The string has a search path where it looks for a method whose name is upcase. And when it finds it, it executes it. If it doesn't find it, you get a method missing error. This is a diagram actually from my book, The Well-Grounded Rubyist. And what's going on here is, if you look at the bottom, we create a new object and send it the message X. Now this just gives you a sense of where an object looks for methods. In this case, we're looking for a method called X. Going to actually not find it according to this because it's not actually defined. The first place it looks is actually in what I've referred to as the Singleton class of the object, which is really just a storehouse for methods that belong only to this object. And in fact, Singleton classes are only created sort of on demand. Objects, just for efficiency reasons, objects don't even have a Singleton method unless you, or sorry, a Singleton class unless you define a singleton method or open the class explicitly as I've done here. Now the singleton class, this notation, class arrow arrow object, that actually opens up the singleton class of the object. And what I've done here is I've included a module called n. What that means is, as the object searches for this x method, after it looks in its singleton class, it will look in any modules that are included in that class. So it goes off and makes this, what I think of as kind of side trip to the module n, does not find a method called x, comes back to the main track, and goes up, and now it's at the class D, which is the class of this object. So it's now looking in its original class and saying, is there an X method? Well, no, there isn't. Okay, how about any modules that are included in this class? Well, there's a module called M that's included in this class, so let's go look in M. Is there an X method? No. So back we go and up to the superclass of D. Notice that D inherits from C. We look in C, we find that there's no X method, and it actually would go beyond that. Once you hit sort of the top of your class tree, it would then go up to the object class, the kernel module, which is included in object, and then finally up to the basic object class, which is really the top of the tree. And if it doesn't find it there, it's failed, and you get a method missing error. This is just a little bit of sort of showing the lookup in action. Again, the person class with a name accessor. I create a person object named David. I'm now going to create a module called vocal, which simply has a method called talk. And it's a little bit tightly coupled with the person class, admittedly. It depends on the name method, but will give me a free ride on that one. How's that? So we have a method called talk, which basically just says your name. Now, class person, I include the vocal module. That means if I say put sDavid.talk, David, the object David, this person object, now has access to a talk method. And notice one important thing here is that when I created David did at that time did not have a talk method because there's no talk method in the person class. But even after I've created the person object, I can include a module in the person class, and even the pre-existing objects will be able to find the methods that are in that module. It's all about what the object knows at the moment that you send it a message. So I send it the message talk, and at that moment, all it cares about is there such a method in my class? Is there such a method in a module included in my class? Yes, there is, because it includes vocal. So that's a good illustration of the fact that all objects care about is what is the state of things at the time that you send them the message. All right, now I have a second module called loud, and what this does is it actually calls super, which what super does is super walks up this path of method searching and finds a previous definition and executes that. So it's going to walk up the class and module path looking for a method called talk. And it's going to find it. Sorry, I should mention, I then do class person include loud. So now when I say put sDavid talk, it says, hi, my name is David, but in capital letters with exclamation points, because now it's loud. Now one thing here, this is a little bit of a contrived example. Well, most of them are in this talk, but one thing that this illustrates is the order of execution when you include more than one module. The object, when I say put sDavid talk, it actually finds the talk in the loud module, and the loud module finds the talk in the vocal module. Basically, when the object is doing this search through classes and modules, when it's looking at modules, it goes in reverse order of inclusion. So the most recently included module will be the first in the search path, and then the next, then if it doesn't find it there, it goes to the next one, and so forth. or in this case, super takes it to the next one. So there's a very sort of, strict set of rules governing the method lookup process. And then this one is just an illustration of extend. In this case, what I've done is I've said module quiet, define talk, and this is, multiple parentheses just to show you how quiet it is. And what I do here is I take the David object and I extend it with quiet. And when you extend, it's similar to including a module, except it's on a per object basis. So what I'm saying is, most person objects are going to talk loud at this point. But this one person object I'm extending with the quiet module. So now when I say David.talk, I get the result of the quiet version of talking. So basically, you can manipulate, where the object is going to find the method, where along the path it's going to either find it or fail to find it, and it's good to know again that objects are looking along a path of modules and classes. The object does not itself sort of possess the method. All right. Classes and modules are objects. The answer to 75% of all questions about Ruby is because classes are objects. Me. And it's really remarkably true. There's a lot of things that get clarified when you totally grasp this idea that classes are objects. Because classes and modules are objects, and classes sort of are modules. Actually, the class is a subclass of the module class. So classes and modules are very, very similar objects, not in every way, but in a lot of ways. But classes and modules are objects. Therefore, you can send them messages, right? Just like you can with any other object. You can put them in collections. You can assign them to local variables. Perhaps one that causes some confusion is the fact that a class can actually have its own instance variables. Every object in Ruby has, at least potentially, a stash of instance variables that represent the private state of that object. Well, since a class is an object, it can have its own instance variables. It can have its own private state. It's not something you do every day. You don't necessarily, always have a need to give instance variables to class objects. But it's good to understand that you can, because the class itself is an object, and therefore it has, sort of all of the rights and privileges connected with being an object, like being able to have its own instance variables. Here is just, again, a little code illustration. I have a class person. I assign it to a local variable. This is just to make it clear that it's the object that matters. It's not the fact that it's referenced in a constant like person. You can put it in, you can bind it to any identifier. I say David equals myClass.new. So even though my class does not begin with a capital letter, the object it evaluates to is a class, and therefore I can call new on it. The commented outline is if I say class my class, that doesn't work because the class keyword does expect a constant. So you can't just drop in a local variable in that position. However, you can do something like myClass.classEval, and what that will do is it will put you into a class definition block that's based on that class, and then you can proceed to define methods and so on. So there's, as usual, there's sort of, related alternate techniques for doing stuff that at first it might seem you're not allowed to do. All right, so classes or objects is an important one and worth sort of playing around with. Point number 5, there's always a self. Now, self plays several different roles. Whatever object is self at a given moment, and there's always exactly one, it's the default receiver of messages. So if you're in a context where a string is self, then if you just say like downcase and not string dot downcase or even self dot downcase. A sort of bare word like that, Ruby, well, first it will try to resolve it as a local variable, and if it fails, it will try to resolve it as a method being called on self. So self is the default receiver of messages when you don't specify a receiver and you don't have a dot. Thank you. They like that. Okay. Self is the owner of all instance variables. Now, this is a really important one, and this leads to a lot of confusion, and it's worth really internalizing this. Every time you look at Ruby code and you see an instance variable, at whatever, that instance variable, without exception, belongs to whatever self is at the moment that it's being executed. Every instance variable belongs to self. So, if, for example, well, one of my favorite examples, actually, if I say, well, let's just say class C. It doesn't much matter. Now, look what I've done here. I've created an instance variable. This also connects up with the point about classes owning their own instance variables. So that instance variable belongs to self. Now, what exactly is self at this moment? Well, if we evaluate self, we find that self is the class C. So that instance variable, let's go back in here. We'll just, I don't actually have to do it again, but now if I say def misleading method, now here's what's going to happen. I say c.new, and I'm going to say c misleading method. Anyone want to walk into my little trap? What's it going to print? It's so mean of me. I really shouldn't do that. Well, let's just say if you glance at it, you could easily, and many people have, assumed that it will print 1 because look, you've got, you're assigning to an instance variable var equals 1. 2 lines later, you're printing an instance variable. The reason it doesn't print 1, it prints nil. The reason is that self has changed. And that second line where I say at var equals 1, self is the class object. 2 lines later, because I'm in a method definition, self is an instance of this class. So it is a different object. Yes, it is an instance of the class that was self before, but they are the class C and the C.new object are two unrelated, other than the fact that one is an instance of the other. They're unrelated. They're not the same object. They do not share instance variables. So what's happening is that Ruby is being very literal and saying every instance variable belongs to self. And as far as it's concerned, I'd never initialized the one that's on line 19, right? That defaults to nil because I actually did not initialize that particular variable. The value of self changes. It will flip to something different. In a class definition where it becomes the class itself. In a method definition, and again, this sort of echoes the example I just showed, where itself becomes the object that we'll call the method. In instance eval, it becomes the receiver of instance eval. Instance eval is basically a way to flip self to be something else. If you want to change self for the duration of a code block, you use instance eval, and the object on which you call instance eval becomes self for that code block. And in class eval, it becomes the class and module. So there's places, kind of fairly small number of places, but important to grasp, where self will actually change or flip to another object. This is just kind of tracing self at different points. One thing to note is that, self in the class definition body comes out as person. Self in the instance method comes out as the person instance. Again, notice the difference. This is the class, this is an instance. The one in the middle, self at the top level, main, When you're at the top level, in other words, you're not inside a class definition, you're not inside a method definition, you're just floating in sort of Ruby outer space. Ruby creates this special object called main, which really exists. It's kind of the backstop object. It's like it exists because there has to be a self. So it sort of bootstraps the object model by creating this sort of default object, main. And that's why when I say, show me self at the top level, it actually comes out as main. If you type main, you can't actually refer to it as main. That's just the tag or sort of wrapper name that Ruby gives it. But that's the top level object before, or the top level self before you enter into any context where self is going to be changed. This is just a quick example of instance eval. String equals I am a string, and I print self, and then I do string.instance eval, and here I say self is now self and put s uppercase. Basically what's happening is, again, in that second line, self is main, right, because I'm out in the top level. When you do an instance eval, you swap in self. I've swapped in the str, the string, I've swapped that in as self for those 2 or 3 lines. So everything that happens in that instance eval block happens in relation to the self that I've called instance eval on. Class eval, similarly, here I've actually just created an anonymous class. My class equals class.new. If I print self in a class eval, it's going to be the class that I've called class eval on. So self is important, and again, there's always one, and it does change from one object to another. All right, point number 6: variables contain references to objects. What that means is, for example, here I say string equals hi, and then I say string 2 equals string. Now, what I've done here is I've copied a reference to a string from one variable to another. And I put it that way to make it clear that I have not copied the string. I still only have one string object. And you can tell that because if I append the word there to the second variable through the use of the second variable, and then I print out the first variable, the there is there, right? In other words, I've manipulated the original string by using a second variable, and that's because each of those variables contains a direct reference to that exact object. So there's no copying going on. It is actually the same object. And that, again, can be a source of some confusion, especially at first when you're not sure why objects are being damaged in mysterious ways. This is just an example using an array. Essentially, I create an array of 3 objects. I copy the reference into array 2. I then add an element to array 2, and sure enough, when I print array, that 4th element is present. So again, I'm using references to manipulate objects, but every reference refers to the same object, every copy of the reference. Now here's one that's kind of a slightly cautionary tale. I have a variable called 1, which is the string 1, and then I have an array that consists of 1, 2, 3. Notice 2 and 3 are capitalized and 1 isn't. If I capitalize 1 in place using the capitalize bang method, then I've changed the string 1 to capital O, and that is also reflected in the array because the array contains that same object, that object 1. Here you see the results, or it's kind of similar behavior in the face of a method call. Here I have a method called addBang, which takes a string and just adds an exclamation point to it. And you can see if I call addBang on a string, or using a variable, using a reference, it operates on exactly that object, because then when I print it out, it has the exclamation point. The method does not copy the string. It does not return a copy. It actually operates on the original object and the object reflects that change. Note, however, that if you use plus on strings or plus equals, you actually do get a new string. So if I say string 2 plus equals there, that is not going to affect the original string because I'm actually reassigning. I'm reassigning to the string 2 variable a new string that has the word there at the end. So if you want to not, or if you want to use copies and so forth, and you can use the plus equals, and that will kind of diverge one object away from another. All right, be careful with freeze. The thing with freeze is that if you freeze an array, for example, if I have an array, I freeze it, I try to push something onto the array, I can't do that. But notice that I can change the first element in the array, right? I can say array sub 0 dot upcase bang, and here I've actually changed the first element in the array to its upcase version. So be careful with freeze, and this is, sort of, it's a little bit tangential to this, but it's sort of related to references too. You just want to be careful that even if an object if it's a collection object and it's frozen, the items in the collection are not frozen. That's what you have to be careful with. All right, finally, just a little bit about true and false. True and false in Ruby are objects, but true and false are also states. Every object has a Boolean value, either true or false. Those are the states. Only two objects have the Boolean value false. Those objects are nil and false. Every other object in Ruby is true. So 0 is true and empty strings are true and so forth. Now, that's usually, if it is a source of confusion, it's usually pretty brief. So, coming from other languages, a lot of people expect 0 to be false, for example, but it isn't. And you can always run a sort of truth test if you, in anything where you can put an if, and here there's, again, a couple of sort of whimsical examples where I'm testing the truth of a class definition. So if class A end, put as true. Well, that's going to return nil, so that will not be true. If class A 0 end, put as true, that will output true because class A 0 end evaluates to 0, which is true. So this is really just to illustrate that you can, and this may be more of a mental exercise than something you would do literally with if statements, but you can always, anything you want to know the truth value of, you can plug into an if statement, and if it passes that, then it's true in the Boolean sense. All right, just a little summary of what we've covered, the 7 points. And again, my goal in doing this is to give you hopefully the benefit of some of my observations over the years of things that people have found confusing, things where people have had great sort of aha moments because they, it's like, classes are objects or whatever. Or, self changed because I entered a method definition. So hopefully, like I said at the beginning, hopefully some of this will, be helpful to you personally. It may be that if you work with people or are mentoring people who are learning Ruby, it'll give you a little bit of, some ideas about trouble spots to emphasize and make sure that they understand. And I am going to stop here. I have a few little things, but we'll I think end here because we're just about out of time. Are there any questions? Yes.
Suggestions for avoiding the references when you want value. So if you just dupe your objects all over the place, that I guess prevents it, but maybe doesn't look so nice.
Yeah, you can dupe to avoid the reference problem. Yeah, I mean, duping is certainly one way. You do have to be careful also, though, like remember that duping is not a deep operation. So if you dupe an array, you actually get a new array, but it has the same objects in it. So you can't, you have to be careful about that. It's a shallow dupe operation.
We have with Rails all the time with options hashes, for example.
Sorry, what's it?
In Rails, for example, options hashes are always duped.
Right.
But you're still working on the original object, usually.
Right.
So do you have any suggestions for other approaches to avoid? I mean, we're hearing a lot about immutable objects in other languages, and inheriting that philosophy a little bit. Do you have any suggestions?
Right. I don't know. I think duping is it's the thing that comes to mind. I think it's not to say there's nothing else, but that's sort of the bread and butter technique. Somehow it ends up not being too huge a problem. I'm not sure why exactly, but just people don't write that many methods that change their argument. I mean, I think it's sort of a bad practice anyway to change, or a questionable practice to change the, if you send an argument to a method to actually destroy it and not, kind of silently change it unless there's, some really compelling reason. But so I think people just avoid some of those things that get them into trouble that way. Yes?
Some of the more subtle or exotic behaviors that you outlined there, are they actually defined, are they discovered behaviors, or are they defined? Is it really intended that Ruby would be like that? And then I suppose the extension of that is, is that a C Ruby, and does J Ruby, Vinius, and all the other Rubies comply? Because there's a few of those things, especially one or two layers below, where you can see variations and interpretations of.
Yeah, I think, and I mean, anyone might be able to prove me wrong about this. I think I've stuck to things here that really are in the language, like the fact that everything reduces to an object, so like a class definition. Again, there's not that many cases where you use that fact directly, but I believe that it is sort of inherent in the language that everything, that a class definition would evaluate to an object, and if it's empty, it would evaluate to nil. Now, I'm not sure. There's been talk about, for example, having method definitions evaluate to symbols that are the name of the method and things like that. I don't know whether any other implementation has actually done that. I don't think so, but that's something where you could, because Ruby makes very little. I mean, basically any method definition, whatever's inside it, the definition block itself evaluates to nil. So that's, in a way, it's kind of a wasted opportunity, because it could evaluate to a name, it could evaluate to a method object, whatever. So I'm not sure whether any of the other implementations have sort of stepped into that particular space. And it certainly could happen, but I think most of what I've covered would probably, would apply to all of them.
In Rubinius, you get a compiled method.
You get what?
A compiled method object.
Okay. So in Rubinius, you get back a compiled method object. Okay, went from a method definition body. All right, so I didn't really talk about those, but that's an example where something sort of, in this family of things might differ from one to another. All right, thank you very much.